Well, hello everyone, and welcome to another episode of Math with Audrey, late night version. So, hopefully, you guys are doing well on Holy Saturday. As I mentioned, I was going to be here after church, and of course, yes, church is still going. So, yeah, I can only handle so much with crowds for up to like 2 hours, and this was going to be a 3 hour event. So, not doing that one. So, if anything, I'm here to kind of show somebody wanted to learn a little bit more of the Pythagorean Theorem. So, as we can see, Pythagorean Theorem is basically for our right triangles. That means we have this angle just 90 degrees, and the sum of the two opposite angles, or the rest of the angles, is going to be also equal 90. So it could be a 45-45, or it could be a 30-60, or anything of the above. So now, these two sides that is adjacent or right next to the 90-degree angle, those are called your legs. So when you have the legs, the opposite side, so the side that's always directly across from that 90-degree angle, that's called your hypotenuse. Okay, the hypotenuse is always going to be your longest side. So it doesn't really even matter if this triangle was rotated some other way, if it was rotated like this, or if it was rotated some other way like this. Okay, it doesn't matter. No matter what, the side that's directly across or opposite that 90-degree angle is always going to be your hypotenuse. So the formula for Pythagorean's theorem, so let me zoom in right here for you, is going to be your a squared plus b squared equals c squared. So the a and the b, they're both your legs. They're interchangeable. So it doesn't matter which one's going to be a, which one's going to be b. However, your longest side, your hypotenuse, that is always going to be your c. Okay, so regardless of what happens. So there might be times that you need to find one of the unknown sides. So what you're going to end up doing is looking at what's called a square root or a radical to break concepts down. So we're going to take a couple examples. I think I have a total of like 7 examples that we're going to be looking at Pythagorean's theorem. And a lot of you guys should know Pythagorean's theorem almost to heart right now. Okay, so here we go. All right, thank you all for coming on in. So first thing that we have 12 inches for one leg, and so many jokes come to mind. And then we have an unknown x for the other, but the side that's directly across from our 90 degree, that is going to be our hypotenuse. So I'm going to have HYP for hypotenuse. Then this is going to be one leg. And then this is the other. All right. So we are basically looking for this unknown side. So some people were like, oh, well, I know what it is because we know about the hypotenuse or the Pythagorean triplets. Okay. But say that we don't know that. So we're looking at our a squared plus our b squared equals our c squared. So remember, it doesn't matter which one's going to be my a. I'm just going to make the unknown side be my a. I'm going to have my 12 squared, and it's going to equal my 13 squared. So all we're doing is basically solving for x. So if we take a look, we have our x squared. We bring down our plus sign. Now, what is 12 squared? And don't say 24. Okay? 12 is being squared. So that means that base of 12 is multiplying to itself 2 times, aka 12 times 12. So what is 12 times 12? Okay, so we got Rise saying 144, Algebra -1. Hello, saying 144. Shinoosh? Is that how you pronounce it? I think that's what it looks like. I think that's an N in between. That's 144. Okay, it's not 24 protected by number 3 because you're not multiplying the 12 to the 2. It's 12 times 12. All right, so 12 times 12 gives me 144. There's no way that is a 5. Try again. There you go. All right, now what is 13 squared? 13 squared. Oh, for your final answer? Okay. So what is 13 squared? All right. So Elk Hunter says 169. Rise question mark says 169. Why are you doing the what? What's the name of the theorem? Okay. So now we're looking for our unknown side. So how do I get my x squared by itself? What do I have to do to both sides? Okay. So what do I have to do on both sides? Because Siri says so? That's cute. Yes, we're definitely going to have to subtract. So we always do the opposite. So we have the opposite of 144. So now we have x squared is going to equal to my 169 minus my 144, which that does, and someone said earlier, that would give me 25. Now, this is going to be the second part of our session, okay? So when we have x squared is equal to 25, we want to find the inverse of square. Now, the inverse of a square is not a circle. It is the square root. Squares and square roots are inverses of each other. So that means my x is going to be by itself. And then the square root of 25, which we saw earlier from a couple people, is 5. But in actuality, our answer is not just 5. Okay? When it comes to square roots, you always have 2 solutions. You actually are going to have a positive 5 and a negative 5. But because of this situation, we can't have a negative length of a side. So that's why we really just focus on the positive 5. Okay? So anytime you break down a square root, you're really given 2 solutions, a positive solution and a negative solution. Okay? And it's not 5 squared, it's just going to be the 5. All right? Okay? So I see one person saying, how come we don't use this in reality? You actually do. Maybe you personally are not using it in reality, but if you're doing any kind of construction, if you're doing any kind of decision making, really trying to figure out which ways you're going to solve, if you are going to design or do any kind of coding, or if you're going to do basically create another way of getting up in the mornings, okay, without using an alarm or having certain music or certain tones, all that is a part of this, okay? So this is called the Pythagorean Theorem. I don't know what the other person was calling it. Okay, so this is the Pythagorean Theorem. So now let's figure out for the other side. So again, we have our unknown sides. So as we look, the side that's directly across from that 90-degree angle, that's always going to be our hypotenuse. That's always going to be our longest side. That means the 2 remaining sides, those are your legs. So those legs are interchangeable. So if you want, you can have your a squared plus b squared equals c squared. So if you want to, you can say, all right, I got 3 squared plus 4 squared equals our unknown side squared. Okay. All right. Okay. So now let's take a look. 3 squared, that will give me my 9, plus the 4 squared, that will give me my 16, and that will give us our x squared. All right? So 9 plus 16, again, that gives us 25. But 25 is going to equal to x squared. Now, the inverse of x squared, we're going to have to do the square root, which will give me not only positive 5, it gives me positive and negative 5. But since we can't have a negative length of a side, that's why we're just focusing on the positive. So that negative solution, that's called an extraneous solution. Okay? The extraneous solution. All right? Nice. So, stepping it up a little bit more. Okay? So what's the difference between this one and the first one? Other than the lengths of the two sides. That's the only difference. Okay? So just the length of the two sides. Basically the length of the sides. All right. So, number 3. Okay. So now we're taking it a step further. So instead of whole numbers, which in fact giving us a perfect square root, now we're going to have some decimals, and this is going to make it a little more realistic. Okay. So again, the side that is directly across from our 90-degree angle, that's going to be your hypotenuse, your longest side. Your other two sides are going to be called legs. So if we go back to our formula, we still have our a squared plus b squared equals c squared. So the two legs are interchangeable, okay? It doesn't matter which one's your A and which one's your B, but the most important is your hypotenuse has to be your C. So we could say x squared plus 11.9 squared equals 14 7/10 squared. All right. All right. So the first one we solved for one of the legs and the other one we solved for the hypotenuse. Okay. Yes. All right. Yes, Pythagorean Theorem. All right. So now we have our x squared. But now what's 11.9 squared? Okay. So remember, it's not just going to be 11.9 times 2. No, it's 11.9 squared. So I definitely should see something with the answer of 3 digits before the decimal point. If it's 2 digits, that means you just multiplied the 11.9 times 2. Okay. All right, so Marcus says 141.61. Okay, if we agree. Okay, Tamara said the same thing. All right. One's like this. How would you know x is squared and not b squared. Does that make sense? So with apples and peas, the a and the b, they're interchangeable. It doesn't matter which one you make the x and which one you make the b. The one that's vital is the side that's directly across from the 90-degree angle. Okay, so whatever the side that's directly across from the 90-degree angle, that's going to be your C. That has to be your C. Okay, but these two are interchangeable, so it doesn't matter. Okay, all right, not a problem. All right, so we are in agreement with 141.61. And then what would be 14.7 squared? What would be this hypotenuse squared? What grade level is this? It's basically Algebra 1. Okay, it's basically Algebra 1. Some people will also see it in early, probably mid-year of geometry as well. Okay. All right, good. Can you do SOHCAHTOA? Not this evening. Yes, 216.9, 216.09, 216.09. Okay. Yep. Cool. Look forward to it. All right. Good. Hello, Lisa. Yes. So let's get this in. 216.09 or 900ths. So now we want to get x squared by itself. So we're going to take our 216.09 and subtract the 141.61. So that means my x squared will equal what? Good. It is. And it does. And it takes practice. And you guys got to understand, like, you're not going to be super geniuses as soon as you walk into the classroom. Okay? It takes time. All right? All right. So Nate says 74.48. Do we agree with Nate? Thumbs up, thumbs down. Yep. All right. Anyone else agree? So 216.09 minus 141.61. There we go. Line with us. Yes, yes. Good. All right. Science is your strong subject? Nice, Craftman. Awesome. All right. So now we want to get x by itself. So we want to take the square root of both sides. And I know for a fact, because 74.48, that is not a perfect square root. So it's not going to be nice and easy and sweet like we just had it. But if you do the square root of both sides, the square and the square root cancels out over here. So that brings me with my x. So we're going to have to probably do approximation because I think it's going to be a long decimal. All right, so let's take it to 4 decimal places. Oh, you guys are reading my minds. All right, so we have 8.6301. And we have one person that switched it to 8.6302. So we have 4 people that. Yes. Because what's after the 1? Everybody hating on Nate. Why are you hating on Nate? Because, take a look. All right, take a look right here. So we have 8.63017. So if we're taking it to 4 decimal places, that means I'm looking at the 1. That's where I want it to go. But the digit before it or after it is a 7. if it's a 5 or above, so that means if it's 5, 6, 7, 8, 9, that means I'm going to add 1 to the previous spot. So I'm going to add a 1 to the 1, which will give me my 2. Okay? If it was 4 and below, so meaning 4, 3, 2, 1, 0, that means that part will just be gone and you just stay right where you want to round to. All right? So it's going to be approximately 8.6302. Okay. No way. This is Algebra 1. I'm in Algebra 1, and we're not doing this. Now, here's my thing. Kimberly, I hate to tell you this. This is supposed to be in Algebra 1. So, right now, the school year is not over. So, probably close to the very end, they're probably going to sneak it in there. But remember, some states put it in Algebra 1, some states put it into geometry, some states put it into Algebra 2. So a lot of districts, a lot of states, everyone does it differently. In Maryland, Pythagorean Theorem is supposed to be in Algebra 1. Okay? It is supposed to be. How do you do the square root by hand? Well, I'm going to show you how to simplify it as soon as I'm finished with Pythagorean Theorem. All right? All right, not a problem. Okay, so this is our answer, but make sure we're going to have it in kilometers. Okay, like this is supposed to be in miles, and this last one was supposed to be in inches. Gotta always remember to put our measurements down. All right? Okay. Well, thanks for the follow, guys. You got it. All right, so now we're going to take it to another level, which does anyone else need any more practice with Pythagorean Theorem? Because I want to kind of introduce you to how to simplify some radicals. Okay. Should be 3 sig figs. Well, we did it in 4. I wanted it in 4. Unit squared. Well, we're not finding the area, apples. Can I just call you apples? Because really, name's pretty long. So we're not finding the area. If we were finding the area, it would be my kilometers squared. Okay, but since we're finding the length of one of the sides, it's just going to be kilometers. Okay. All right. Okay. All right. Okay. Why what? Why do I want it in 4? Because I just wanted it in 4. we have some power here. That's why I want it. I wanted it in 4. If you want to give it to me in 3, you can give it to me in 3. All right, so, okay. All right, so now we're going to go into simplifying radicals. Now, simplifying radicals, hey, Michael, how are you? Has to be by itself. It cannot be mixed with digits. It's like, can I explain? Can you explain? Not really. Okay, so if anything, we got parts of a radical. So now with a radical, you'll have like an index. Sometimes there's a number there. And then what lies underneath the radical is called a radicand. So the lowest form of a radical that you can have is a square root. Okay? There's no such thing as a 1 root. All right? So the lowest that you can have as a radical is a square root. So one thing that we do a lot in our classes is we do a lot with square roots, but there's other different types of roots. So we can have a cube root. Okay. So when we have a cube root, we know it because there's a 3 representing my cube. So I need to know, okay, what number multiplied by itself 3 times will give me 8. So I know a lot of people would like to break it down like this. So you have your cube root. You know that 2 to the 3rd power, because that's 2 times 2 times 2. 2 times 2 gives me 4. 4 times 2 gives me 8. And what they like to do from here is to cancel out the 3 and the cube root. Because the cube and the cube root, they're inverses of each other. They're opposites. So when they cancel out, what's left is our 2. So the cube root of 8 is actually 2. All right? Oh, sorry. Okay, so we got cube root. Yes, good. Now, right, exactly, Nate. So you can do anything. You can have a 4th root. So the opposite of a 4th root is to the 4th power. The opposite to the 5th root is to the 5th power. To the 6th root, 6th power. 7th root, 7th power. Okay? Keeps going on and on all the way to infinity. But majority of the times that you're going to see in most assessments are going to be square roots and cube roots. Once you get into, like, say, pre-calculus and calculus, that's where you're going to see more of the 4th root and the 5th roots. Okay, so mostly for the algebra, algebra 1, algebra 2, maybe even sometimes in geometry, they might throw it in there once in a while, not too often. But mostly algebra 1, algebra 2, you'll see square roots and cube roots. So, opposite means inverse. Yes. Why do they cancel? Because they're opposites of each other. Think about it. It's almost like if I had a positive 3, the inverse of a positive 3 will be a negative 3. Okay? So positive 3 and negative 3 will give us 0. Okay? So they're opposites. There you go. Okay. So now we're going to work on simplifying radicals. But we don't want to simplify it. That means we're putting in the calculator and we're getting a decimal. Because when you get the decimal, you're going to round it. Just like when I asked for the last question for you guys to round to the fourth decimal place, you are taking away from the value of that number. Okay, you're just kind of like, it's almost like if someone's name is Catherine and there's a huge history about the word Catherine in her family, and you call her Katie, or you call her Kiki, or whatever people are calling Catherines nowadays, right? Kathy, okay? But you're taking away the value of that name by giving them a nickname, right? Same thing is happening with radicals. Same thing happens with fractions. When they ask you to give them the exact value of a number, leave it as a fraction. If they say to do it as an approximate, that's when you can put it as a decimal. Okay? So I know everyone's got rules, right? Kate or kitty cat. There we go. Okay. So let's start off with something like, say, the square root of 18. Okay? Let's give a nice little example. All right. So with the square root of 18, 18 is not what's called a perfect square root. So that means if I go with my perfect squares, I'm going to try to just list them out real quick. I'm actually going to put it over here with formulas. So say the square root of 1, that gives me 1. The square root of 4, that gives me 2. Square root of 9 gives me 3. And we all know there's a plus minus. But we're just going to focus on the positive for this exercise. 25 gives me 5. This gives me 36. 49. And plus this might help some people when we want to break some stuff down. And I'm going to see if I can squeeze square root of 100, square root of 121, square root of 144. We kind of talked a little bit about that. Square root of 169 gives us 13. I think it's 216 if I'm not mistaken. I'm surprised I'm able to do a lot of this in my head. No. 196. And then we got our 225. All right, so, okay. Just wanted to make sure, because I am doing this in pen, being very rebellious. Okay. All right. So now, it's not plus or minus. It can be plus or minus, yes, unless you're dealing with lengths. There you go, Nate. Thank you. All right. A lot of things, Rise, a lot of things. Okay. So, these are going to be considered my perfect square roots. Because if I squared 1 squared, 1 times 1 will give me 1. 2 squared, 2 times 2 will give me 4. 3 squared, 3 times 3 will give me 9. And so forth, right? So because we have this, when we're breaking down a square root, we're looking for a perfect prime combination. So 18, as we can see, the square root of 18 is going to be between the square root of 6 and the square root of 25. Okay, so there is not a perfect square root of 18. But we can break it down so it can have, remember prime factorization back in the day? When math was simpler. We need to think of two numbers multiplied together that will give me 18. But here's the thing. One of them needs to be a perfect, and the other needs to be prime. Okay? So, here's a little bit of background. What is the first prime number? I just want to see if you guys get it. What is the first prime number? Because I'm seeing my answers up here, which is awesome. Okay. Okay, I see a couple of ones. I'm seeing 3. Oh, no, 4. Pog with the dose. Okay. All right. The first prime number is not 1. Because the definition of prime is the only way you can get that number is 1 in itself. But if 1 is 1, and 1 is constantly being used, 1 is being used to factor for 2, 1 is being used to factor for 3, 1 is being used to factor for 4, for 5, for 6, for 7, so forth. So your first prime number is not 1. It's actually 2. And 9 times 2 does give me that 18. All right, so 9 times 2, that does give me that 18. So those are 2 factors, yes. All right, now, square root of 9, that's your perfect. Because the square root of 9 gives me 3. So the square root of 9 can be broken down into a whole number, which is 3. But the square root of 2, since it's a prime number, it can't be broken down. you're going to get some kind of crazy decimal. So if you can't break it down, then just simply bring it down. So without disturbing the value of the square root of 18, we just simplified it in a way that we can probably do lovely things with it in other situations. Okay, so yes. So we got 3 square root of 2. Okay. Let's try another one. So let's say we have square root of 32. I always get several different answers for this one. So the square root of 32. Right now we're simplifying radicals. Okay? So you're saying the 4 root of 2, that's what Quiz Me is saying. So what was my perfect, Quiz Me? You're welcome. How did you get your 4? Okay, so we got 16 and 2, 16 and 2, you're 16. Okay, the 4 and 8, okay? So Lisa, I'm glad that you did that. Okay, I'm really glad that you did that. So I'm gonna actually put 2 of these bad boys up here. You're like, oh no. It's okay. Because this is what learning is all about. Okay, we do 4 and 8, that's one of them. The other one will be 16 and 2. Okay, now, if we do the square root of 16, that's one of our perfects. Okay, so that's one of our perfects. The square root of 16 will give us a 4. So it gives us this whole number of 4. So it's no longer underneath the square root. But the square root of 2, that's prime. So if I can't break it down, I bring it down. But just like my friend Lisa, she notices that, well, 4 and 8 can also be factors of 32. That is true. And the square root of 4 is a perfect square root, which does give us 2. But the square root of 8 is not prime. That means that square root of 8 can be factored down again. What will be 2 factors multiplied to give me an 8? Okay. So I think it was Lime. Oh wait, no. You said 4 and 2. Okay, Lisa saying 4 and 2. So we got square root of 4 times the square root of 2. So again, square root of 4 gives me 2. This time we have the square root of 2, and that is prime. So if I can't break it down, I bring it down. But this whole number of 2 that we originally had is actually being multiplied by this whole number of 2, because these are like terms. So 2 times 2 will give me my 4, and the square root of 2 just comes on down. So the reason why I wanted to show both of these is to show that you're going to get the same answer regardless. You're going to do a few more steps for one, but you will eventually get the same answer. Okay. True. William, that's true. Okay. Because if you made that into 2 to the cube, it'll be kind of, you could. But since we're dealing with the square root, it's going to be hard for me to basically break down. Unless, if I did with the 8s, unless I did this. I have to put them in squares. Meaning I would have 2 squared times 2 to the first. So this will give me my 2, and I will still keep my square root of 2. So that was for William. The reason why I don't want to make it just 2 to the third power is because I'm not dealing with the cube root. I'm dealing with the square root. Okay? So if you are going to group them, you can group them based off of the index, which this will be a square root. All right. What type of pen am I using? I'm just using a Sharpie pen. Shameless plug. Sharpie pen and pencil. If you see the SAT, have you done it these ways? Yes, I've seen components of this. Now, that's the one thing about the SAT picks. The SAT basically takes what you're learning and they put it into like almost thinking outside the box type of situation. So when you're dealing with the SAT and the AC, well, the SAT in particular, they like to mix 2, possibly 3 different concepts in one problem. Whereas the ACT will actually look at your radical. They might put it in a word problem, and then you just have to derive it and solve it. Okay? Or they might give it to you like this, which I like to call naked math. Okay, no word problem is just solve or simplify or evaluate. Okay, that's one of the difference with the ACT and the SAT. All right, so it'll be a way to do it. Yeah. Depends on. So Joella cares. Let me go back to see what you asked. If I can find you. Because I don't like to feel like I'm skipping anybody if anybody's asking. Just listing the person with their corresponding primes. Yes. Okay, and that's why with my book that I'm writing in, this is a book that I created, and I have all of the factors. So I list all my factors from 1 all the way to 200. Okay, so in situations like this, like 32. Excuse me as I organize myself here. So if we got, say, the square root of 32. Notice with 32, we have factors of 1 and 32, 2 and 16, and 4 and 8. What's in red represents that perfect prime combination. So that's 16 and 2. Okay? Anything that is in yellow, that is going to be my prime numbers. What's in blue is like my perfect. So here it is, like if I said the square root of 25, it will be 5 because I got 5 times 5. So I just made like a whole listing. And since we usually deal with larger numbers, unlike like some of the notebooks that you guys see, like the composition notebooks and everything, most of those notebooks are designed for elementary school kids or for journaling. Okay, it's not really designed for math. So I just figured, let me design a math notebook and take it from there, right? Just to help organize thoughts. All right, thank you. Okay, so now, how about, let's do this one for our next example. How about the square root of 30? Square root of 30. See if we can simplify the square root of 30. What days do I go live? I try to go live at least once every day. At least once every day. But usually during the week, I try to get on like around 9:30, 10, because now I'm starting to get some of my clients. Okay. All right. Thanks for the follow. Here comes Christine. All right. This is not just 1 square root of 30. Okay. Is it not just 1 square root of 30? Okay. So you can't simplify it at all? Okay. You don't know? Okay. So if we take a look at it, 2 numbers multiplied together give me 30. Okay. So we always want whole numbers. Okay. So Lisa's telling me 6 and 5. So the square root of 6, square root of 5. Now, square root of 6 is not a perfect square. Okay. Because if I tried to break down the square root of 6, I'm going to get the square root of 3 times the square root of 2. Okay. And then 5, that's prime. Okay. Because that's just 5 times 1. I can't get a perfect out of this at all. Right? So in a way, this is basically my answer. I know, that's ugly, right? So that's why most people that are doing math, knowing that you can't break it down any further or get a perfect square root out of it, they'll say it's called prime. Okay. Square root of 30 is one of those special square roots that we can actually break some things down. But we don't get a perfect square root out of it. So since we don't get anything out of it, it's going to be one of those special prime square roots. Now, what I mean by that is, well, I already mentioned one. Let me slide this over for a sec and unzoom just a major hair. So let's say the square root of 6. Because when we tried to break down the square root of 6, we got 2 prime numbers as a result. We had the square root of 3 and the square root of 2. So square root of 6 is one of those special radicals. Square root of 10 is also one of those special radicals, because the only thing, if I try to break down the square root of 10, I'm just going to get 5 and 2. 2 prime numbers. Can't do anything with it. Same with the square root of 14. Only thing I can get out of 14 is 1 and 14 and 7 and 2. Guess what? Boom. More prime numbers. Square root of 15. Because all we can get is 5 and 3. Let's see. Square root of 21. Because all we can get is 7 and 3. And I want to say there's another one with 21. Well, 22, that'll be 11 and 2. But the other one that you'll see the most will also be your square root of 30. There is more, but these are the most popular ones. Okay. Okay, so these are like your special radicals. Special prime radicals. Okay. Yes. So sometimes square root. Okay, never mind. All right, good. All right, no one can be taken out of the root. Right, so nothing. So the only factors of 15, yes, is 5 and 3. For 10, it's 5 and 2. For 6, it's 3 and 2. Okay? So kind of noticing, what is this? We're simplifying radicals. Okay? I remember now. There you go, developer. All right. So sometimes we'll come across these special prime radicals. And when you see it, you don't have to, like with SATs or any of those state assessments, don't stress yourself out like, oh, I know the square root of 14 can be broken down. Like, yeah, but is it helping you? If the answer is no, just leave it as the square root of 14. Don't give it the decimal. We always want to be as exact as possible. All right. On the ASVAT, there might be some components, especially when you are dealing with using the Pythagorean Theorem to, like, say, find the distance of something or find the height of a building, or like find out how tall the flagpole is, if its shadow is 50 feet away from the base of the thing. Yeah. So sometimes you might see it on occasion here and there. But if you do for the ASVAT, you want to hit hard with a lot of the algebra components, meaning your equation of the line, system of equations, that's in there. Your mean, median, and mode. Your and range, even though range is variation, but we'll go through that. Also, your distance, rate, and time. Those word problems are going to be in there. Simplifying fractions is going to be in there. Factoring is going to be there, because the higher you go, if you're trying to score high, you're going to see more of the factoring. That's going to be on the ASVAT as well. And I always say, like, if you're trying to get your GED, remember, all of the problems are not graded the same. You're going to have some 1-point problems, which is basically your fractions, which one's bigger based off the number line. But when it gets to the algebra component, like trying to write the equation of the line and graphing the equation of the line, knowing lines that are parallel or perpendicular, how can you tell? Those are 4-point questions. You want to get as many as those as possible. And with the sprinkling of those 1-point questions, like changing a fraction to a decimal, that's a 1-point question. But if you can get a lot of the algebra parts, you'll definitely pass the test. If not, ask Lisa. She just passed it recently. This is awesome. All right. Identify these types of numbers. It doesn't, but I'm going to add them in. I was starting to work on my other algebra book. So doing today, Michael. And working on my notes as well. Today was an interesting day. Okay. No, we're not doing SOHCAHTOA tonight. Okay. I might be able to throw it in. I wasn't planning on it, but I might throw it in there. All right, so let's try this one. I don't know why this question gets a lot of students, and sometimes it makes me crazy. The square root of 300. So I know I can break down radicals with variables, but I'm not doing variables tonight. But this one gets students all the time. What do you think the solution, if you could take a guess? All right. If you could take a guess. Okay. So all my examples right now, picks, if you go to my YouTube channel, all of my lives I have recorded. Okay, so if you go to Audrey Codner ACG Math Tutoring on YouTube, all of my stuff is on there. So you can definitely see how to graph an equation line. Actually, we did a couple of those last night. Okay. Did a few other things too, and also probability is in there, all of that. Okay. All right. Okay. So we got 10 root 3. Okay. Then we have 30 and 10. Then we have 10 the square root of 3, 103. Yes. Now, people, love you dearly. Here we go. When you want to break down the square root of 300, 200, 500, 1000, factor out the 100. Make your life easy. Anytime you see double zeros, factor out that 100. All right? You factor out the 100 because remember, this is multiplication that's going on right here. So 100 times 3, that will give me my 300. Now, this square root of 100, that's one of our perfect square roots, which gives me an answer of 10. And now we got the square root of 3. Square root of 3, that's prime. So if I can't break it down, I'm going to bring it down. Okay? You could do 10 and 30. That means you will have to break down 10 into 5 and 2. Okay, let me show you. So if I did, let's say devil's advocate, we did 10 and square root of 30. That means I'm going to have to break this down into prime factors. Meaning, square root of 10 will give me the square root of 5. Square root of 2. Square root of 30 will give me the square root of 5, square root of 6, but the square root of 6 is also square root of 2 times the square root of 3. Okay, so I'm going to bring all this fun stuff down. Square root of 5, square root of 2, square root of 5. All right, all of this is multiplying. Now, this will also help you when you're trying to rationalize your denominator. I'll explain when we get to that later. But if you notice, we have square root of 5, square root of 5, square root of 2, square root of 2. Square root of 5 times square root of 5 gives me the square root of 25. Here's the shortcut. When you multiply and they have the same radicand, your answer is going to be that number without the square root. The reason being is if I do the square root of 25, we know the square root of 25 is a perfect radical. So it's going to give me an answer of 5. So if you are multiplying and you have the same radicand, the radicand is what's underneath the square root symbol. If they're exactly the same, it's going to give you that number without a radical. So same thing is happening with the square root of 2's. Square root of 2 times square root of 2, that would give me the square root of 4. And what's the square root of 4? It's 2. Okay, so shortcut. Square root of 2 times square root of 2 will give me 2. Square root of 5 times square root of 5 will give me 5. Then we have this lonely square root of 3. If you can't break it down, bring it down. So now you got 5 times 2. Because they're whole numbers. You always multiply whole numbers with whole numbers, radicals with radicals. And you will still get the same answer of 10 square root of 3. Just less monotonous. Okay? So the square root of x times the square root of x is just x. Yes, it is, Nate. Yes, it is. Thank you, Campbell. Square root of 3, that can't be broken down. I know. We feel bad for them. But we can get it as close as we can. Okay? It's probably that cute friend of yours that you're just like, we could date, but it will make things crazy. Okay? So we'll get as close as we can without just mingling in, right? All right? I mean, it's just like the math. Okay. Well, welcome. Welcome in. All right. So I think we get the idea of it. One more, and then I will do our little SOHCAHTOA, and then we are done for tonight. Okay, one more, relatively easy. Square root of 50. Okay, square root of 50, relatively easy. What is my solution? What is that simplified version of the square root of 50 without losing the true value of the square root of 50? Yep, friend zoning the square root of 3. Right? So we can do 10 and 5. What else could we do, Lisa? What else could we do? What else can give me 50? Think of that perfect prime combination. Yes, I'm seeing this. I'm seeing Tiana, 5 square root of 2, lay 25 and 2. Is that La Chupacabra? Cabron? That's cute. 25 and 2. Okay, MV, 25 and 2, and 5 square root of 2, 25 and 2. All right. Okay. So, root 2. Love it, Michael. All right. So, 4 square root of 50. Okay, shameless plug. Let me show you through my book. All right. So, if I look up 50, coming down here. So if I did the square root of 50, we got 1 and 50, 2 and 25, and 5 and 10. We can still use 5 and 10, but we'll just have to break down that 10 again. But that perfect prime combination will be my 25 and 2. Because the square root of 25 makes it so much easier and a little bit cleaner for us to figure it out. So we got square root of 25, square root of 2. I love putting my perfects in front of my primes because when I break it down, I'm going to have my 5, and then I just bring down my square root of 2. Because if I don't, it's going to look something like this. It's going to look like square root of 2 with a 5. And this is how our brain is going to do it. Oh, okay, our answer is 5. And then they're like, why is it wrong? Why? Okay. Because it looks like that 5 should be underneath that square root, which it is not. Okay. So, or we'll just erase it. So it's not going to be that as I shake everything on my desk. Because this camera is being held by a wind and a prayer. All right. Okay. So you could, as I said, you could do 10 and 5. Break down the square root of 10. So that gives me 2 and 5. And I bring down the square root of 5. Then I notice I have 2 square root of 5s. So square root of 5 times square root of 5, that will give me my 5. And then we bring down our square root of 2. Okay? So you could do it. Okay? You could do it. But sometimes it's nice to see what is that perfect that I can pull out. All right? So in order for me to get my final answers. Okay? Questions on that? Let's take a look. Do you use an online platform to tutor? Like Varsity Tutors trying to get a job? I have my own tutoring business. After I left the classroom about 5 years ago, I just cannot work with other people, and plus knowing that they're taking a good 50, sometimes 75% of the money, and we don't get that much. So I just decided to start my own. So if you are interested, I do tutor or actually mentor other tutors. So just send me a message, Gambrel, and then we'll sit down, we'll chit chat, and I'll just tell you the truth, because it is possible. And yes, you can make a living with that. Okay. Yeah. I just felt like I still wanted to teach, but I just couldn't take the foolishness anymore. I really couldn't. And plus all the stuff that's going on nowadays, not a huge fan. So, all right. As promised, I think this was for our lovely mate, Nate. Ooh, got a little crazy with us. All right. So, Nate wanted us to go over a couple things with SOHCAHTOA. Because when you think Pythagorean Theorem, the next thing that jumps at you is usually SOHCAHTOA. Now, what is SOHCAHTOA? You're probably saying. I'm going to see if I can steal one of our triangles from earlier. I'll do the 5, 12, 13. We'll do that. I know it doesn't look like it, but hey, that's the one thing about geometry. You cannot trust your eyes. You always have to prove things. So you can't say, oh, that looks like a right triangle. You got to prove it. Does it have 3 sides? Yes. What are the measurements of the angles? Okay. And then now you're not just proving it as a triangle. You're proving it what type of triangle it is. So when it comes to geometry, you cannot trust your eyes. But when it comes, we have something called SOHCAHTOA. So we have so, we have ka, and we have toa. Now, this is in reference to whatever your angle is. And right now, this is supposed to be the Greek symbol called theta. Based off of theta, based off of this angle, we can claim that the side directly across from theta is going to be my opposite side. The side that is adjacent or next to theta is my adjacent side. And like we said, no matter what, the side that's directly across from my 90-degree angle is my hypotenuse. Okay. Yep, I did do Pythagorean earlier. I'll show it in a moment. Okay. So, what's going on? There we go. So, SOHCAHTOA is just a quick, cute little way of remembering which side goes with which symbol. So the so is talking about the sign of your theta. Okay? Actually, I'm going to do the abbreviations because I think a lot of you guys recognize the abbreviations. So we have our sine. Then we have our cosine. Cosine deals with adjacent over hypotenuse. Then we have our tangent. And our tangent deals with the opposite side over the adjacent side. So let's get to that part first before I start talking inverses. So it's all based off of my theta, okay? So if I want to look for the sine of theta, I'm looking at opposite this theta, which is 12, over the hypotenuse, which is 13. So that's the ratio that's representing the sine of this angle degree of theta. If I want to do the cosine, here's theta. So cosine deals with my adjacent side, which is 5, over my hypotenuse, which is 13. Okay. When am I going to do calculus? Calculus is really not my jam. I'll be truthful. I'll get you to limits, and then I'll pass you over to my friend that's a guy. I got a guy. Right? Alerts today. Oh, I'm sorry. Well, this is the only one. So I just went on to this one. But it's okay. I'll show you the notes of it. I'll kind of give you a quick run through. All right. So now for tangent, again, the tangent of theta. Tangent is your opposite, which is 12, over your adjacent, which is 5. So most of the time when they ask you, what is the ratio to the following trig functions, that's what they're doing. One, it's all based off of whatever angle they're calling theta. Sometimes they put a theta, sometimes they might actually put a measure. Let's say this is, we could say 30 degrees. Let me make this a little bit darker. Okay, so let's say they want us to look at the sine, cosine, and tangent of the 30 degrees. So that means we're looking at the sine of 30 degrees. And that means we're using this angle. So my opposite is no longer going to be 12. 12 was opposite of theta. But the opposite of 30 degrees is now going to be 5. But the hypotenuse stays exactly the same, which is 13. Okay? Hypotenuse is always going to be the side, your longest side. Okay? All right. So now, if we do the cosine of 30 degrees, cosine is going to be adjacent. So if this is opposite for 30 degrees, that means the other leg is going to be adjacent, which is my 12 of 13. And for me to find the tangent of my 30 degrees, I put my degree symbol. So your tangent of 30 degrees is going to be your opposite, which is 5, over your adjacent, which is 12. Okay. How are we feeling so far? Okay, good. All right, so it's all based on which angle you're looking at. Okay, it's all based on what angle you're looking at. All right. So, just like most, everything has a inverse, has a flip. So the flip of sine is going to be cosecant. That's the inverse of sine. The inverse of cosine is secant. Okay, notice the S and the C's kind of flipped. Sine starts with S, cosecant starts with C. Cosine starts with C, secant starts with S. Okay, so it's never an SSCC situation. Okay, you always have an SC or a CS type situation. Now for the tangent, this is really hard right here. Ready? Tangent, the opposite is called a cotangent. Yeah, they didn't go too far. Okay, so the inverse of tangent is cotangent. Okay, so the inverse of sine is cosecant. The inverse of cosine is secant. And the inverse of tangent is cotangent. And all you're doing for the inverse is flipping. So if for my sine of 30 degrees was 5 over 13, my cosecant of 30 degrees is going to be 13 over 5. That's it. So what would be the inverse? What would be secant of 30 degrees? What would be the ratio for that? Yep. Good. Yep. Pog. Yes, you can do that too. But we're trying to do the basics. Yes, Ashley. So we have 13 over 12. Okay. So now what will be my cotangent of 30 degrees? That's it, Ashley. Is it this is an interesting one. Is it asida? Asida or asada? Okay. I hope I got that right. I'm sorry. And I got user ones. Yeah. Awesome. For the people. Awesome. Okay. We're flipping it. Lisa and all of them. Good. All right. So you just basically looked at all 6 of the unit functions. Oops. The trig functions, all 6 of them. So it's sine, cosine, and tangent. So soon enough, you're going to be doing calculations with it. And if you notice, those are probably those 3 buttons that you're always wondering, what are they for? Well, soon enough, you're going to be seeing what they are for, okay? One is going to help you figure out the side, and the other one, sometimes they use it to figure out the angles. All right, so side, sine, cosine, tangent. But then you have something called the arcsine, arccosine, arctangent. Arcsine, arccosine, arctangent. Okay? All right. So, that's your intro to trig. Okay, that was your intro to trig. Good job, guys. Excellent job. Okay, so let me do a quick rundown of those a little bit later. Okay, so, let me unzoom a lot. So we talked a little bit about Pythagorean Theorem. So we know, if we take a look, we have our 2 legs, they're A and our B. They're interchangeable when you're doing the Pythagorean Theorem. But the side directly across from the 90-degree angle, that's your hypotenuse. That's always your C, your longest side. Okay? So when you are trying to find the length of one of the other missing sides, so if we take a look at number 1, it doesn't matter which one you made your unknown side. You can make your A your unknown side like I did here, or you could have made your B the unknown side. But no matter what, your other leg has to be accounted for. But your hypotenuse, your C, is always going to be the side that's directly across from that 90-degree angle. That's why 13 squared is over here. So the formula for Pythagorean theorem is a squared plus b squared equals c squared. We plug in our information. 12 squared is not 24. It's 12 times 12. That's where the 144 came from. 13 squared, same thing. It's 13 times 13. That's where the 169 came from. Okay? We subtract the 144 and we got 25. In order for us to get rid of this square, we had to do the inverse, which is square root. So when we took the square root of both sides, the square and the square roots, they're opposites of each other. They cancel each other out, which that's where that x came from. But now, coming out of a square root of 25, it always gives us an answer that's positive and that's negative. But since we're looking for the length of a side, we can't have a negative length. So that's why we focus solely on the positive answer. So that's where x equals 5 is our official answer. Yep, the hypotenuse will always be the sum of the square of the two sides. Okay. All right. Okay, thank you so much for the follows, guys. My eyes, my leg. It always reminds me of SpongeBob episode. All right. Okay. So things can kind of change up, especially this side over here. This time, our unknown was our hypotenuse. But our two legs are interchangeable. It didn't matter which one was going to be my A side and which one's going to be my B side. So I just said, okay, 3 squared, that's my A side. 4 squared, that's my B side. But it's going to equal x squared. That's my hypotenuse. So 3 squared gives me 9. 4 squared gives me 16. 9 plus 16 is 25. In order for us to get rid of this square, we have to do its inverse, which is the square root. Once we did the square root, just like the first one, we're going to get a positive and negative 5, but we can't have a negative length of a side. So that's why we focused on the positive. Okay. Yes. All right. Is everyone doing okay? Okay, we're somewhat caught up. Yes. All right. Thank you, Adam, for the follow. Okay, we're pretty much caught up here. That'll be awesome. Yes, not a problem. Okay, so tonight was Pythagorean Theorem. Can't even speak. Pythagorean Theorem and simplifying radicals, and we did that part. Okay, that was this part over here. Let me unzoom and possibly get rid of that. Okay, so we're looking at our perfect square roots, and we want to keep the value of the number. So we're not just putting in our calculators and spitting out the decimal. Because when you're doing the decimals, you're going to be rounding. And when you're rounding, you're not giving me the true value of the number. Okay? So all you're doing is just finding the estimate. Okay? We want to have the true value. All right? So with that, we have the breaking down of the radicals. And then we just added a little touch based on a little request on our trig functions. There's a total of 6 of them. But when you're first starting, you hit heavy on the sine, the cosine, and the tangent. Then you have your inverses, which is your cosecant, inverse of sine, secant, inverse of cosine, and cotangent, which is the inverse of tangent. All right. Well, it's going to seem hard. You came towards the end. It's not like as soon as you were born, you're breakdancing. No, you had to learn to lift your head up and learn how to digest your food and, learn how to crawl before you can walk. Okay. But again, as I said, I did create this workbook. If you're really into a notebook just to organize your notes a little bit, hey, go ahead and just hit my picture in my profile, and you can go to my website, ACG Math Tutoring, and I am working on getting all of my notes copied. Most of them are copied now, and basically putting together what's called Audrey's notes. So there used to be Cliff Notes back in the day. If you want to get a copy of my actual notes with the particular videos of our lives that's connected to it, I will be putting that on my website. Give me another couple of days. It's taking a little bit longer than I expected, just like everything else in life. But if you can do that, that'll be great. So tomorrow I will be on, I want to say 8:30 Eastern Standard Time. It's going to be a little bit earlier because I need to get some sleep. And I think that's probably what's causing a lot of my little issues that I'm having. So if anything, 8:30 tomorrow night, we're going to be working on fractions. Okay? And I might put a little bit of dabble of some word problems that is going to deal with your distance, rate, and time. Okay, so tomorrow is going to be really basic. Okay, really holding your hands for how to break down, how to add, subtract, multiply, divide, proper fractions, improper fractions, mixed numbers, as well as look at our distance, rate, and time type of word problems, because they are definitely in GED, SAT, ACT, ASVAT, definitely. What's the other one? Acuplacer, that's definitely in there as well. Okay, so if we can hit on those concepts, that will be amazeballs. Now, again, if you can help me out, go ahead, subscribe to my YouTube channel. It's going to take me some time to upload tonight's video on there, but it will be uploaded by the morning. Like when I say the morning, I'm talking about 8, 9 o'clock. But I'm going to try to get it done before I go to Mass in the morning. But if you can, do a Google review. If you can do a Google review, go to ACG Math Tutoring, because this is almost like tutoring. So if you can help me with my numbers there as well, some of you guys have, I greatly appreciate it. But also increasing the subscriptions. We have no idea what's going to happen with TikTok. Everyone keeps using this as a little carrot. But if this ever shuts down, that's where I'm going to be going to. Okay, I will definitely be at my YouTube. All right, so I will see you guys tomorrow at 8:30. Okay, 8:30, I'll be there. All righty. Okay, any other questions? PM Eastern Standard Time, 8:30. That's what I'm going to be. All right. Yeah, no, not 8:30 a.m. You're funny. 8:30 a.m. for my video. About 8 o'clock, the video should be up by then. Tonight's recording, replay, should be on my YouTube channel. But me going live, no. I gotta go and praise God. Okay? Thank him for all you guys coming in and visiting me. Thank you for all you guys taking the step up and wanting to better yourself or entertain yourself with math on a Saturday night at 11 something p.m. Hilarious. Love y'all. Okay, so happy Easter. Oh, California Living, how are you? It has been way too long. Happy Easter to you. Okay, please continue to keep up and stay good to yourselves. Please don't let anyone tell you that you do not amount to anything. Good. I'm glad you're good because it's been a minute. Just keep pushing forward. I know it's not easy. Trust me, I know it's not easy. But it's going to be worth it. All that hard work that you're putting into, it's going to be worth it. All right? Okay? So, happy Easter to you guys. Stay safe because we all know there's going to be a couple crazy people that want to do something stupid, and I don't want anything to happen to you. Okay? This should not be the last time that I talk to you. Okay? Shouldn't be. Should not. All right? All right, guys. Take care. Love you all. Thank you so much for the likes and for the gifts and for your time and attention. All right? Have a good night, and I'll see you tomorrow. All right? Love yous. Bye.